Now, we have to answer this question. It is about a trolley, and it reads that a trolley of mass 80 kilograms is initially at rest on a horizontal surface. It is connected to a 20 kilogram mass by a light inextensible rope running over a frictionless pulley as shown. So this is now the pulley, and then you have a mass of 80 kilograms, then you also have a mass of 20 kilograms. Let us call this mass here mass 1, and let us call this one mass 2. Now, you are required to find this acceleration. So the question is, what is the acceleration of the masses when the system starts to move? This is what you are going to do. So we will say now, from Newton's second law of motion, we have force equals to mass multiplied by acceleration, where we are saying that the F represents the accelerating force. And then we have got the M is a mass of the system, of masses equivalent to M1 plus M2, where I have told you we refer to this as M1 and this be M2, so that the system of masses now will be the sum of this M1 plus this M2. Note the fact that the surface is frictionless, so there is nothing that will affect this frictional force, this accelerating force. We'll just have to use it the way it is. But if we had it, at least you would have found a need to find the net force, having accounted for the frictional force. So now we have got to say that force equals to what? But we do not have the force here. There is this arrow pointing upward. This represents a tension due to the weight of this 20 kilogram mass, and we are saying this one is equivalent to the weight, except that it is acting in opposite direction as the weight. So we would say that the force is equivalent to the tension, and that is equivalent to mg, which is now 20 kilograms multiplied by 10 newtons per kilogram, which is acceleration due to gravity, and this gives us 200 to be the accelerating force. What about the masses? So it will be the sum of m1 plus m2, giving you 80 plus 20, and here you have got the sum of the system of masses to be 100 kilograms. Therefore, the force being equivalent to MA should now look like 200 newtons equals to the 100 kilogram mass, which is mass of the system, multiplied by the desired acceleration. So therefore, acceleration will be equivalent to 200 and 100, and this gives you 2 meters per square second. That is the acceleration that is required. We had the frictional force, then we would have said that the accelerating force F would be equivalent to the tension minus the frictional force, and that should have been equivalent to mass multiplied by acceleration. But because we do not have that in this case, that means we have to see that next. See you then.